Cool. Yeah, like I said before, my name is Lindsay House. I'm a third year PhD student at the University of Texas, Austin. And yeah, I'm going to talk a little bit about my citizen science project that I have created, Dark Energy Explorers. And yeah, it was really exciting. I appreciate you guys for having me. It's exciting to hear all the different places that you guys are from. You're making me miss Boulder. Yeah, I just wanted to give a little bit of an overview of where we're going. Like I said, I'm going to try and give you a quick spiel of my project. But again, would love this to be a discussion and get some advice from you guys, but also want it to be helpful for you at the same time. So I'm going to talk a little bit about HET-DEX, which is the Hobby-Eberly Telescope Dark Energy Experiment, which is the umbrella project that Dark Energy Explorers is under. And then I'm going to talk a little bit about the data that we have collected, the education work that we've done, which is where I would love to hear advice or feedback from you guys, as some of you are education researchers or experts in outreach and engagement, and talk a little bit about some of the things that I've done that's worked for us, and then see if you guys have any feedback. But particularly on the education research, the different data or research questions that you guys might have in mind. So starting off, just what is citizen science? It's essentially a collaboration between scientists and those who are just curious, and getting the general public involved in science, motivated to make a difference for a larger science goal. So HET-DEX is the project that my advisor PIs, which is the Hobby-Eberly Telescope Dark Energy Experiment. And it's this really cool experiment. We have the Hobby-Eberly Telescope out in West Texas. And it's super unique in that it's an unbiased spectroscopic survey. So unlike most telescope surveys that are searching for different objects, this one we just point up at the sky and we're going to collect data for about 7 years, and then create this map of the universe. And so we're going to collect about 1 billion spectra, and we'll have about 1 million galaxies from about 10 billion years ago, or about redshift 2, if that means anything to anyone. And so this is going to help us understand dark energy. And so this is me at the telescope. We're out in West Texas. We're part of one of the biggest international dark sky reserves. It's about an hour away from Big Bend. So if you guys ever take a trip out to Big Bend, make the extra hour drive to the observatory. It's really awesome. They do star parties and things like that. So HET-DEX is essentially going to create this map, and this is one of the first maps. It doesn't look that exciting, but this is one of our first maps of the universe that we're creating. All of those tiny little dots there are galaxies that we are collecting. And so this is the first look at some of these galaxies, and this is the data that we're actually giving to our citizen scientists and to the public, and they're getting to classify these galaxies. And this is essentially like the cartoon image of the picture that we're trying to make. Here's us down here with our telescope looking back all the way to the Big Bang and trying to map out all of those galaxies from the beginning of time. And so we have all of this data. You guys can imagine we're collecting data every night for over 7 years. And we need all of these galaxies classified. Like I said, we're not pointing at specific objects. We don't know what they are already. We're just pointing that telescope up at the sky and collecting as much data as possible. So we need to classify all of this data. And so it's impossible for us to do it as a small team. We just really time inefficient, right? We've tried machine learning, and right now our initial results show that we need a better training set. It's really, really hard. Our signal to noise from our telescope is just really messy. But what's really cool is the human eye's ability for pattern recognition is actually superb. So we have employed citizen science and created a project to get the public involved to help us classify all of these galaxies, which will then create this training set so that then we can go back and use machine learning or we can go back and have a smaller subset of galaxies to look at ourselves as our in-house team. And so Dark Energy Explorers is the project that I launched on Zooniverse, which is our host platform. It's one of the world's largest citizen science platform where anyone can be a researcher. You just need the internet. And we have two different workflows. And so the first is called nearby versus distant, where you're looking for closer galaxies versus farther away galaxies. And then the other one is fishing for signal in a sea of noise, where you're swiping back and forth, figuring out the real galaxies and the real signal versus the fake galaxies, which are maybe like detector faults or false detections that we get from our telescope. And so our participants, you can download a mobile app, Zooniverse, or you can go to our website, and participants learn through a tutorial. This is meant for people without science backgrounds. I tried to get rid of all of the jargon, so it was really accessible for people who might not be astronomers or might not be within the sciences. I have advertised to, usually I say about 8th grade, but I think middle school is a pretty safe start, but middle school and beyond. And so the tutorial takes participants through these different images and what they're actually looking at from the telescope. And I'll kind of breeze through these, but you're looking at different spectral lines, but we're using things like, you know, the blue dots and the black line are lined up, or the dark dots and the pixels are showing strong emission lines, or large dots versus smaller dots, faint dots. So this is specifically for the nearby versus distant. And so we are, you know, jokingly swiping left for our nearby galaxies, which are the galaxies we don't care about and are not going to help us with our data set. We want those distant galaxies so that we can map the universe farther back in time. So we're swiping right for those distant galaxies. The nearby are, this is an example, large and bright dots, whereas our distant galaxies are super small and really faint. And so we have had a lot of success, which has been super exciting. We launched back in February of 2021. And we've had over about 3.7 million classifications by 11,000 volunteers. We also have, because we're hosted on Zooniverse, a talk discussion board where our participants can post questions or interesting sources that they see, and then we can go, or I can try and go respond to all of their different comments. And we've had about 4,000 comments on that discussion board. But it's also been super exciting because not only do we have 11,000 participants, but we also have representation from over 85 countries all around the world, which is super cool just to see where people are. But yeah, so some of the education and engagement that I've done, I've been mainly focused on the science side of things and collecting the data to then be able to process it to use specifically for the science of HET-DEX, but we have this really awesome, rich education data set that I would love to hear you guys, if you have any feedback about, because I just haven't had the time to explore it yet. But I've tried to do a few different things. One specifically is I've implemented like a pop-up level up incentive for every 100 classifications that a person does. And this educates them, takes them to a page to learn about HET-DEX, dark energy, or just general astronomy, shows them how to maybe be a better classifier so they can find black holes or active galactic nuclei. And what I have been working on is actually taking those classifications from the citizen scientists and implementing machine learning. So it's really cool because you know, it's not like these two projects are separate. It's not like we have this science project, HET-DEX, and we're just kind of doing the outreach for fun. These citizen scientists are actually classifying this data, and they're actually the ones that are doing the science for us, and they're proving to be better than the computers. And we actually need them to train the computers. And so this is a beginning plot of some of the machine learning without the citizen scientists, and you can see it's just a large cluster. We can't really tell what sources are which. But with the citizen scientists, essentially what we can do, we can create labels and we can actually add color to this plot. And we can see where we have those distant galaxies or nearby galaxies. And this has been one of the really exciting things that I think the public has liked a lot, is sharing these results with them and showing them actually how essential they are in doing this science. And so just so you guys know, some of the data that we have available, we collect from Zooniverse, we collect the username, we get like a timestamp of the date and time of their classification. Then we get an individual ID for each source. We can see whether our users are on the mobile versus the desktop computer. And then I have access to all of the comments on the talk board that are linked to the individual's like username and classification. But I have thought of a few other questions as far as education research, and some of them, I think Ali was nice enough to post them in the Padlet, but some of them are like user engagement over time, trying to think about how our users maybe are interacting with that pop-up that we give them. But again, I haven't really done anything as far as the education research side of things, because I've been more focused on the science sort of things. But I'm really excited. We have funding from NSF and NASA, so I have been able to hire 3 undergrads this semester to work with me. And so some of them are actually going to be focusing completely on this research. And so it would be great. I would love to get some advice for projects that they could be engaged with. So some of the outreach and engagement that we've done, just small things, making a QR code. I use the talk board or emailing our volunteers. One thing that I want to do in the future is trying to do like a Zoom session every couple times this semester to get our participants engaged, maybe doing some giveaways and that kind of thing. We have created some materials to work with K through 12 teachers, and I've led a few workshops through the observatory. And this is a picture. I was working in DC this summer. We created some hands-on activities to explain dark energy with balloons and things like that, to really kind of hit home the science while they're also, getting a chance to take a look at these actual galaxies. And then another thing was, getting in informal education spaces like the museums or the observatories. We also have really used a lot of the undergrads or the classes here. We've done some science sprints because undergrads are always looking to do undergrad research, and then that way they get research credit. And then, also like department, CNS as a whole, our College of Natural Sciences has done a lot with us. They just did a press release, and that's helped us get in some like local magazines and radio shows and news and things like that. Or blog posts, like I know AAS, I know most of you guys were in physics, but I'm sure APS or some might have a similar like education blog. So that was a very fast overview of my project, but I would love to hear feedback or have you guys share this in your informal education spaces, or just download the app and let me know what you think. But